and objects in Java. Classes and objects are basic concepts of object-oriented programming which revolve around the real-life entities. Class. A class is a user-defined blueprint or prototype from which objects are created. It represents the set of properties or methods that are common to all objects of one type. In general, class declarations can include these components in order: modifiers. A class can be public or has default access. Class name. The name should begin with an initial letter. Superclass, if any. The name of the class parents, superclass, if any, preceded by the keyword extends. A class can only extend subclass one parent. Interfaces, if any. A comma-separated list of interfaces implemented by the class, if any, preceded by the keyword implements. A class can implement more than one interface. Body. The class body surrounded by braces. Constructors are used for initializing new objects. Fields are variables that provide the state of the class and its object, and methods are used to implement the behavior of the class and its object. There are various types of classes that are used in real-time applications, such as nested classes, anonymous classes, lambda expressions. Object. It is a basic unit of object-oriented programming and represents the real-life entities. A typical Java program creates many objects, which, as you know, interact by invoking methods. An object consists of: first, state. It is represented by attributes of an object. It also reflects the properties of an object. Second, behavior. It is represented by methods of an object. It also reflects the response of an object with other objects. Third, identity. It gives a unique name to an object and enables one object to interact with other objects. Example of an object: cat. Identity, the name of cat. State or attributes: breed, age, color. Behaviors: meowing, sleeping, eating. Objects correspond to things found in real world. For example, a graphics program may have objects such as circle, square, menu. An online shopping system might have objects such as shopping chart, customer, and product. Declaring objects, also called instantiating a class. When an object of a class is created, the class is said to be instantiated. All the instances share the attributes and the behavior of the class, but the values of those attributes, the state, are unique for each object. A single class may have any number of instances. As we declare variables like type name, this notifies the compiler that we will use name to refer to data whose type is type. With a primitive variable, this declaration also reserves the proper amount of memory for the variable. So for reference variable, type must be strictly a concrete class name. In general, we can't create objects of an abstract class or an interface. If we declare reference variable to feel like this, its value will be undetermined until an object is actually created and assigned to it. Simply declaring a reference variable does not create an object. The new operator instantiates a class by allocating memory for a new object and adding a reference to that memory. The new operator also invokes the class constructor. So as you can see here, the output is: hi, my name is Tufi, my breed, age and color are Parsi, 5 white. This class contains a single constructor. We can recognize a constructor because its declaration uses the same name as the class and it has no return type. The Java compiler differentiates the constructors based on the number and the type of the arguments. The constructor in the cat class takes 4 arguments. The following statement provides tuffy, parsi, 5 white as values for those arguments. The result of executing this statement can be illustrated as. So guys, this is the thing that we need to take note. All classes have at least one constructor. If a class does not explicitly declare any, the Java compiler automatically provides a no-argument constructor, also called the default constructor. This default constructor calls the class parent's no-argument constructor as it contains only one statement, super, or the object class constructor if the class has no other parent, as object class is parent of all classes either directly or indirectly. Ways to create object of a class. There are 4 ways to create objects in Java. Strictly speaking, there is only one way, by using new keyword, and the rest internally use new keyword. Using new keyword. It is the most common and general way to create object in Java. Using class.forName, string class name method. There is a predefined class in java.lang package with name class. The forName string class name method returns the class object associated with the class with the given string name. We have to give the fully qualified name for a class. On calling new instance method on this class, object returns new instance of the class with the given string name. Using clone method. Clone method is present in object class. It creates and returns a copy of the object. Deserialization. Deserialization is technique of reading an object from the saved state in a file. Encapsulation in Java. Encapsulation is defined as the wrapping up of data under a single unit. It is the mechanism that binds together code and the data it manipulates. Other way to think about encapsulation is it is a protective shield that prevents the data from being accessed by the code outside this shield. Technically, in encapsulation, the variables or data of a class is hidden from any other class and can be accessed only through any member function of own class in which they are declared. And in encapsulation, the data in a class is hidden from other classes, so it is also known as data hiding. Encapsulation can be achieved by declaring all the variables in the class as private and writing public methods in the class to set and get the values of variables. So this is the program to access variables of the class encapsulate demo. In this program, the class encapsulate demo is encapsulated as the variables are declared as private. The get methods like getA bracket, getName bracket, getRole bracket are set as public. These methods are used to access these variables. The setter methods like setName bracket, setAge bracket, setRole bracket are also declared as public and are used to set the values of the variables. Advantages of encapsulation. First, data hiding. The user will have no idea about the inner implementation of the class. It will not be visible to the user that how the class is storing values in the variables. He only knows that we are passing the values to a setter method and variables are getting initialized with that value. Second, increased flexibility. We can make the variables of the class as read-only or write-only depending on our requirement. If we wish to make the variables as read-only, then we have to omit the setter methods like setName bracket, setAge bracket. from the above program, or if we wish to make the variables as write only, then we have to omit the get methods like get name bracket, get age bracket from the above program. Third, reusability. Encapsulation also improves the reusability and easy to change with new requirements. Fourth, testing code is easy. Encapsulated code is easy to test for unit testing. Abstraction in Java. Data abstraction is the property by virtue of which only the essential details are displayed to the user. The trivial or the non-essential units are not displayed to the user. Example, a car is viewed as a car rather than its individual components. Data abstraction may also be defined as the process of identifying only the required characteristics of an object, ignoring the irrelevant details. The properties and behaviors of an object differentiate it from other objects of similar type and also help in grouping the objects. Consider a real-life example of a man driving a car. The man only knows that pressing the accelerators will increase the speed of car or applying brakes will stop the car, but he does not know about how on pressing the accelerator the speed is actually increasing. He does not know about the inner mechanism of the car or the implementation of accelerator, brakes in the car. This is what abstraction is. In Java, abstraction is achieved by interfaces and abstract classes. We can achieve 100% abstraction using interfaces. Abstract classes and abstract methods. An abstract class is a class that is declared with abstract keyword. An abstract method is a method that is declared without an implementation. An abstract class may or may not have all abstract methods. Some of them can be concrete methods. A method-defined abstract must always be redefined in the subclass, thus making overriding compulsory or either make subclass itself abstract. Any class that contains one or more abstract methods must also be declared with abstract keyword. There can be no object of an abstract class. That is, an abstract class cannot be directly instantiated with the new operator. An abstract class can have parameterized constructors, and default constructor is always present in an abstract class. When to use abstract classes and abstract methods with an example. There are situations in which we will want to define a superclass that declares the structure of a given abstraction without providing a complete implementation of every method. That is, sometimes we will want to create a superclass that only defines a generalization form that will be shared by all of its subclasses, leaving it to each subclass to fill in the details. Consider a classic shape example, perhaps used in a computer-aided design system or game simulation. The base type is shape, and each shape has a color, size, and so on. From these specific types of shapes are derived circle, square, triangle, and so on, each of which may have additional characteristics and behaviors. For example, certain shapes can be flipped. Some behaviors may be different, such as when you want to calculate the area of a shape. The type hierarchy embodies both the similarities and differences between the shapes. Advantages of abstraction. First, it reduces the complexity of viewing the things. Second, avoids code duplication and increases reusability. Third, helps to increase security of an application or program as only important details are provided to the user. Encapsulation versus data abstraction. First, encapsulation is data hiding, information hiding, while abstraction is detail hiding, implementation hiding. Second, while encapsulation groups together data and methods that act upon the data, data abstraction deals with exposing the interface to the user and hiding the details of implementation.